Hi students, this is Mr. Yao. Today we are going to talk about 7.1 Intro to Geometry, where we will learn about new vocabulary for geometry. So during class, we actually asked students to work in groups, and you guys did your research to actually find out some answers for these vocab. And in your notes is going to be a matching kind of activity. But if you actually missed the class, or if you need to go back and look at them again, here's the lesson. I'm just going to talk about each one of the vocab. So let's have a look. First vocabulary, point. It's matching with definition M. And point is something that's no dimension. It is usually represented by a dot. So here is a dot. We'll just draw a dot and typically label it as, like, for example, A, that's point A. Next, line. Line matches with definition K. It has one dimension. It is usually represented by a straight line with two arrows to indicate that it extends without end in two directions. So for example, we have this line. Actually, the A is not there. We have this line, but we can't just draw a line and not knowing how to represent it. So let's say you actually have point on here, A and B, and we are going to represent it in AB with a little line indication on the top. Is the line with two arrows on the top to indicate this is actually line AB. The reason I emphasize on that is to tell it apart from the next definition, which is line segment. Line segment is matching with definition R, a part of a line that consists of 2 points called end points, and all the points on the line that are between the end points. So let's say this is your point, and this is another point. All the points in between them will just basically form a line. And we have starting from A, ending with B, that's a line segment. We typically write with just a bar, no arrows on the top of AB to indicate that is a line segment. Next, circle. Circle matches with definition B. It is the set of all points in a plane that are equal distance from a given point called the center. So let's say you have a point here, and to this direction is that long, to that direction is that long, that direction is that long. It's all the same distance. And then I can connect all of them and actually kind of make a circle. And this point is the center. Which, in other words, if you have a string and a pen, and you pin down one of the end and put a pencil on the other end, just drag around with the string, you are actually going to form a circle, because this is the definition, basically the definition of circle. Next, polygon. Polygon matches with definition N. A closed plane figure that is formed by 3 or more line segments called sides. A closed plane figure, 3 or more, which means a triangle is also a polygon. Another thing is no intersecting with the lines. If you have something like this, for example, that technically couldn't exactly be a polygon. If you have something like that, because this is actually intersecting. So from this line to that line, this point to that point, that forms a line segment. They're actually intersecting. So that is not a polygon. That does not work. Next, regular polygon matches with definition V, a polygon that has all the sizes and all the angles congruent. So for example, if it's a regular triangle, regular polygon that is a triangle, it's actually going to be an equilateral triangle. And to indicate all the sides are the same, we draw a little dash on the side. To indicate all the angles are the same, we draw angles to indicate they are the same. So that is a regular polygon. Then, of course, irregular polygon matches with definition P. Is a polygon that doesn't have all sides and all angles congruent. So, for example, a right triangle, like that, clearly all 3 sides are not the same, so that is going to be an irregular polygon. Next, triangle, a polygon with 3 sides and 3 angles. The sum of a triangle is 180 degrees. That is something very important. That's one important fact about triangles. Next, quadrilateral matches with definition F. It is a polygon with 4 sides. Could be anything. It could be the things that we know, like a special one, like a square, or it could just be like that. Whatever shape, as long as it has 4 sides, that's a quadrilateral. But also we have special quadrilaterals, for example. Next, parallelogram matches with definition J, a quadrilateral with both pairs of opposite sides parallel. So this is a parallelogram. they're not only parallel, they're also congruent. So we can just draw a little dash on these two sides, means these two are congruent, but we can also draw little dashes on the other two sides, but we can't just draw one, because if we only draw one, that means all four sides are the same. We're going to indicate, hey, the one on the left and the one on the right are the same, but it's not the same as the one on the top and on the bottom. So we draw two dashes. The side that has the same amount of dashes means they are actually congruent. Next, a rectangle. A rectangle is matching with definition E. It's a parallelogram with four congruent angles. Just the angles. We're not including anything about the size. The only thing we do need to know is not all four sides are actually the same. But since it's a parallelogram, for sure the opposite sides will be the same. But the angles, since they're all the same, they're all going to be 90-degree angles. So that is a rectangle indicating the 90-degree. These two sides are the same, and these two sides are the same. That is a rectangle. Next, square is matching with definition S. It's a parallelogram with four congruent sides and four right angles. So we're going to draw the right angle here to indicate these are all right angles. And then, since all four sides are the same, we're just going to draw a single dash on top of each side. That is a square. Next, rhombus, a parallelogram with four congruent sides, matching with definition C. Four congruent sides didn't say anything about the angles, so that means the angles could actually be anything. So we are going to draw a kind of an extreme rhombus, just kind of squish it down. These four sides are actually the same and has nothing to do with the angles. We don't know anything about the angles, but that is still a parallelogram and four sides are the same, so it's a rhombus. Next, trapezoid, matching with definition Q. Trapezoid is a quadrilateral with exactly one pair of parallel lines, called bases. So all the special quadrilaterals that we talk about, this is the only one that have one pair of parallel sides. So it's not a parallelogram. Here's an example of a trapezoid. These two, the top side and the bottom side, are parallel, and then the other two are called legs, and they are not parallel. So that is an example of a trapezoid. Next, a group of shapes. Pentagon is matching with definition L, is a polygon with 5 sides. Hexagon matching with O, a polygon with 6 sides. Heptagon, H, matching with H, has 7 sides. Octagon matching with A has 8 sides. Nonagon matching with I with 9 sides. Decagon matching with U and is a polygon with 10 sides. Now the last two definitions, concave and convex. We kind of need to talk about them together. They're both going to be referring to polygons, and we're going to talk about the interior angles. When interior angles are actually greater than 180 degrees, it's going to be called concave. And you can see the word cave. It's kind of like caving in. So for example, let's say we have a pentagon. Let's say this is a pentagon. Well, it's caving in right here. So it's not exactly popping out, it's caving in. So that is going to be a concave. Another way you can think about it is, think it as one side is being pushed in to the inside of a polygon. So if you use the side to draw an arrow, well, that is the arrow. It's actually pointing inward. So that is a concave polygon. Next, for convex, let's say it's still a pentagon. Well, you can see everything is kind of pointing out. If you use the sides to form an arrow, that's an arrow, that's an arrow, that's an arrow, that's an arrow, that is an arrow. All the arrows are pointing outwards. So that would be a convex polygon. Now, if you are curious about how to check the angles, well, these are the interior angles for these polygons. Well, clearly they're all less than 180 degrees because 180 degree would be a straight line, And this one, for example, that is less than 180, that is less than 180, but this is less than 180. However, this interior angle, that is not less than 180. That's why it doesn't work. That side is greater than 180 degrees. So that's why that's a concave and this is a convex polygon. Now that is all the definitions we're going to learn for now, and that is the 7.4. Thank you.